Welcome. Thanks for coming again for this week's briefing. This week we have Dr. John Nese who's here. It's been an interesting past couple of days. A lot of southeast PA has seen a pretty appreciable amount of snow today, but there's some good news, I think, in the future that we may be warming up. So Dr. Nese will give us the details. Thank you.
Thanks, Ryan. So, Ken Reeves graduated from this department in 1983. He's a classmate of mine. He passed away unexpectedly on March 25th, 2012, so it's been almost 3 years. Ken was a big reason that the department and AccuWeather had linkages. He was really the liaison there. He was a driving force behind these briefings, and for that reason, when he passed away, we decided to name these briefings after him. So I think it's kind of important to begin by at least letting those of you who are new to the department know who Ken was. So the overview, we're being barely grazed today by a significant winter storm. It's a storm that will end up being the biggest storm of the season in a lot of places, and there's really no cyclone of any note on the map. It's a perfect example of how you can make a synoptic scale storm without a strong cyclone. Instead, you have a strong boundary and you have a moisture plume. Tonight may very well be the coldest night here until December. The record low for March 6th is -1. I suspect we'll be close, but probably not. Tomorrow will be unseasonably cold. The record min-max for March 7th, which is the day based on the way we do observations here, the high temperature for tomorrow will go on the card that says March 7th, is 16. I don't think we'll break that, but it won't get very warm tomorrow. 20, 22 maybe. And then generally dry and getting milder starting on Saturday, which I think is, well, it's welcome news to me. I'll speak for myself. So we've been so far from climatology for so long that most of us have probably forgotten what climatology is. The mean, max, and min for today are 42 and 25. Our last day above average was February 10th. That means today makes 24 in a row. The records for today are 73 and 3. The normals will be 48 and 29 by March 20th, so Vernal Equinox. We're gaining about 2.5 minutes of daylight per day right now, and don't forget that daylight saving time begins Sunday, believe it or not. So I thought I would spend a couple minutes, and I do literally mean a couple, on the past. So these are the temperature anomalies over the last 90 days. Fred was kind enough to direct me to the web version of the graphics that appear on the e-wall. So it's been quite a ride. There have been a couple days in there where State College has been 30 degrees on average below the long-term mean. We've completely forgotten that the winter started out rather tame. The December anomaly, departure from average, is on the left. Most of Pennsylvania was between 2 and 6 degrees above average in December. You're not going to see too many charts like the one on the right with monthly anomalies in the state more than -12 in some parts, especially along the northern tier. If you're interested in more statistics about the chill of February, just watch Weather World. What I've found kind of remarkable about this stretch of cold, there are two indices out there that are routinely computed by the Climate Diagnostics Center, and certainly some of you have heard of these. One is the NAO, which, without getting into the details of what it means, essentially, when this index, which quantifies the upper air pattern, basically, you can compute the NAO just by looking at 500 millibar heights. When this index is negative, that tends to mean that cold air that comes into the eastern United States can't move out quickly. And so a negative NAO favors chill in the eastern United States. This index has been positive by this goes back to November. This index has been positive for most of the winter, and it was positive during our recent cold snap. Now, another way to quantify upper air patterns is to look at an index called the PNA, or Pacific and North American Index. Now, this index, when it is positive, and again, you can compute this index with 500 millibar heights. It's not hard to compute once you know the secret. When this index is positive, it tends to suggest ridging along the west coast. And ridging along the west coast favors troughing in the east. And the point I'm trying to make is that what I've found remarkable about the cold that we've just gone through is it was done solely on the shoulders of a positive PNA, that is a ridge along the west coast, without any blocking out over the Atlantic to keep the cold air from moving out. This has just been one air mass after another of frigid air coming in such rapid succession that we weren't able to ever recover to any degree. So that's one thing that sticks in my mind about this remarkable stretch of chill. Those of you who are still hoping for some snow, we're up to 47.6 right now, which is slightly above the long-term mean. Interestingly, it doesn't matter if you measure average snowfall with the traditional National Weather Service 30-year mean, or if you use the long-term mean that goes all the way back into the late 1800s. Coincidentally, both of those means ended up at 45.3 inches. Those of you who are still hoping for a big snow should know, and every time I do a briefing in March I show this, that the 3 biggest snowstorms in State College history, and 5 of the top 10, all occurred in March. So there is hope if you're looking for the whopper, the big one. To make this list, obviously, you got to have a snowfall of 18 inches or more to make the State College top 10. When you look at the breakdown of all 10-inch snowstorms that have occurred in State College over the years, and there have been 85 such storms since the 1890s, so you can do the math, that's about less than 1 a year. And these are broken down by the half month in which they began. So find the snowstorms, ask on which day did it begin, and then create a frequency diagram. There are as many, and I use 10 inches as my threshold for a big snow. You might have a different definition. That was mine. There are as many big snowstorms in State College in March as there are in February. And in fact, the peak, as you can see, is during the first half of the month of March. The way things are setting up, there's no hope. There's little hope in the first half of March this time. So looking at the current situation, I grabbed a couple model runs from earlier in the week just to kind of show how this is the NAM from 6Z on Monday. This is the NAM from 12Z yesterday, valid at 15Z today, so valid at 10 a.m. this morning. And they all captured the essence of the pattern. The cold front had moved well to our south, there, here on this run. If you look at the GFS from those same times, the 6Z GFS from Monday, valid 15Z today, 12Z GFS, they all had the same idea. A powerful front had moved to our south. There were some weak waves along it, but really not a significant cyclone. The northern edge of the significant precipitation was unknown. There was a considerable amount of uncertainty. The GFS has always been a little less bullish on snow here than the NAM was. I think the GFS observations seem to suggest, at least in State College, the GFS has verified better. This is a very significant boundary. The packing of the thickness lines on its cold side suggests a very large horizontal temperature gradient in the lower troposphere. And so most of the precipitation that's falling right now, and I don't have the radar yet, is falling on the cold side of this boundary, which really is a cold front more or less along its entire length. So those of you who know the terminology, anafront is the name we give to a front where the precipitation's falling on the cold side of the front, surface front. So all warm fronts are anafronts, but cold fronts, generally speaking, some are anafronts, but many are the opposite, catafronts. This is a cold front acting as an anafront, with the vast majority, if not all of the precipitation, falling on the cold side of a boundary where the cold air is still advancing. So I kind of like to think of this as overrunning at a cold front. Though we typically associate the term overrunning with precipitation at a warm front, So you might not want to use the word overrunning. You can use another word, but essentially that's what's happening here, is that this boundary is being overrun and most, if not all, of the precipitation's falling on the cold side of the boundary. And there really is no significant cyclone. These are just a couple of, I like looking at this product because it's a blend of 57 models, including some of the ensemble members from the European, and these nice probability products. So I grabbed a couple snapshots. This was Monday afternoon, probability of 4 inches or more. State College at that time was arguably between 30 and 40%. By Tuesday morning, the odds of a 4-inch or larger snowstorm in State College had gone up to about 50 or 60%. And as of yesterday morning, this is the 24-hour period ending at 0Z this evening. So this would have been 7 p.m. Wednesday to 7 p.m. Friday. State College still, you can see the gradient at the northern edge, though, was sharpening significantly. So there had always been. Anyone who tried to suggest that there was no ambiguity about what would happen here, I think, was kidding themselves. Now, the consistency, however, was in this corridor, and that is indeed manifesting itself with significant snows from Kentucky through West Virginia into even nearby south central and southeastern Pennsylvania. So look at a couple of the products. As best I can tell, SPC has only issued 4 severe weather watches so far in 2015. But they were busy today issuing mesoscale discussions about the ribbon of heavy snow setting up just to the south of Pennsylvania, essentially right across the D.C. area into Delaware. Here's your current situation. There's the front. Fairly weak area of low pressure along that front. Again, most of the precipitation falling on the cold side of the front. The 500 millibar pattern shows the short wave that's kind of driving all this, still lagging fairly well to the east. You could also argue what's going on kind of using jet streak dynamics, a pretty potent 150 knot jet. You can see the purple isopleth in here is 150 knots, I believe. Jet stream dynamics enables us to argue that this is the right entrance region of a jet streak, which would be a favorable region based on upper level divergence for heavier precipitation to blossom, and I think that works pretty well in this case. Talk about disruptions. This is the PennDOT traffic cam. So there have been significant travel disruptions from Harrisburg to the southeast. We could probably bring up a webcam here and just take a peek maybe on what's going on down here. You know, it's snow. All right. Looks like I-81. There was a jackknife tractor trailer on the turnpike between Downingtown and Willow Grove earlier today. So this is a storm in Pennsylvania, just not for us. There's the Laurel Ridge State Park webcam, where it looks like closing in on 18 inches of snow up there on Laurel Ridge. So here's the meso analysis, modest area of low pressure, 10-12 millibars. One of the neat products on here is a frontogenesis product. Frontogenesis meaning essentially the strengthening of a front, the tightening of the temperature gradient, which makes a front a front. Often, if you look at this frontogenesis product, so you're kind of looking in the layer between 850 and 700 millibars at where the front is strengthening, and often pockets of heavier precipitation are reasonably well correlated with where this frontogenesis or strengthening of the temperature gradient is occurring in the 850 to 700 millibar layer. And it's a little hard to see the contours here, but it's these purple contours are contours of frontogenesis, and they do depict to some extent, the locations where the heaviest precipitation is falling right now. The vapor image shows us a nice connection to the subtropics. One of my pet peeves about using this image, you often see these images and people say, well, look at all this moisture streaming in from the subtropics. And if you only have 3 seconds, then I guess that's what you say. But let's think about that. Remember that the water vapor image focuses mainly on what's going on in the middle and upper troposphere. Generally speaking, the middle and upper troposphere, in an absolute sense, don't have a lot of water vapor. I mean, look at a balloon launch sometime, and look at the mixing ratios at 400 millibars, at 300 millibars, at 200 millibars. They're usually very meager. So to suggest that you're looking at the moisture that's funneling in and producing all that rain and all that snow, I think is a bit misleading. What's happening is this upper level jet stream has disturbances embedded within it that are fostering low-level cyclogenesis, which is generating a low-level flow, which is bringing in most of the moisture. Now, I know on TV you don't have time to say that, but that's really, if you think about it, what's going on. Just prove it to yourself by looking at a sounding sometime and look at the moisture content at the levels at which the water vapor image is sensing the moisture for the most part. Just a thought.
I mean, I guess to add on to that too, one thing I noticed during the precursing storm to this front was the amount of dew point increase during that event. And I think you tweeted out one of the sites.
The dew point in Charleston was 51.
Right.
It was 63 over 51, and that was the air that was being introduced. It was overrunning the low-level chill.
Yeah, and we didn't remove any of that low-level moisture, at least not a whole lot of it. So,
if anything, it intensified ahead of this front. I mean, this is some mighty warm and juicy air. So finally, the radar image, sort of on the regional scale. So it's done in Pittsburgh. We're done. I mean, except for maybe a bit of flakage. This thing will slowly translate northeastward over the next few hours. And really, our weather turns. I couldn't think about what I would say about the future weather because there's really not a lot going on in the future. But let's use this nice Meteorology Department National Weather Service graphic to ask a few questions about the future. So let's look at the GEFS, and let's look at 850 millibar temperatures. And I guess I could go with this. So this air mass coming in, this looks like the caboose in terms of the last really cold air mass, hopefully, as far as I'm concerned, until 2017. The temperature anomaly at 850 millibars, you're looking at 2 to 3 standard deviations colder than the long-term average when you look at that darker blue. And that air mass slides across here. This is 0Z this evening. So this is during the day tomorrow. And this is tomorrow evening. So by the time we get to Saturday, things have settled down. There's really no significant departure from average in terms of 850 millibar temperatures. And indeed, temperatures on Saturday may rebound to within a few degrees of the climatological average. So let me go back to the PowerPoint here. And let's take a peek at a website that I sometimes go to, in part because Bob Hart is a graduate of this department. He's now a faculty member, and he's a friend of Rich's, and a lot of the neat graphics that we like to show are the result of Bob's and Rich's hard work. Here's a look at the next 7 days in cross-section, time across the bottom. Relative humidity is what is colorized here. You can see that the columns of air over us right now are very moist to high altitude. But as one transitions into the next 7 days, you really don't see any times when the column becomes close to being saturated through a deep layer. And that's really suggestive of the idea that There are no significant synoptic scale disturbances on the way. In fact, if one looks at the plume diagrams from the GFS for State College, from the GEFS, any event in our future, whether it be the 9th, what would that, let's see, Thursday, Friday, Saturday, Sunday, Monday. Really, it's a fairly benign pattern. In fact, it has me almost questioning whether winter is over. Here's Moss, and I'll try to support that statement with a diagram in just a second. So Moss has us, it's the dueling Moss tonight, -4 and 6. I found actually that a blend of the NAM and the GFS Moss has done okay during some of these really cold nights. So, I mean, I think 0, 1, or 2 might work here. It's going to depend, of course, on how quickly we clear. Nice agreement tomorrow on the high, low 20s. And then, well, the sky's the limit. We stay overcast, however, on Saturday, and I think that's why temperatures don't achieve what they might, assuming near average 850 millibar temperatures. But long range has us in the 40s by Sunday. I need to have some outdoor painting done at my house, and the painter says it has to be 40 degrees, so I have him tentatively scheduled for Sunday. Does it get to 51 on Wednesday? I don't know. I don't care. If it's 45, I'll be thrilled, as I'm sure many of you will be. This is the average 500 millibar pattern over the latter half of February. Clearly, the mean trough had been situated right over the eastern United States. This delivered. Steve Seaman tweeted something that was just amazing to me, and I'll give credit where credit is due. I don't know if Steve's here today. I can't see any of you unless I put my glasses on. I can see Rich. The last 14 days of February in State College, the average temperature during those 14 days was the coldest ever during that 14-day period in State College by 5 degrees. In other words, it was 5 degrees colder than any previous February 15th to February 28th. I mean, that's really remarkable, and that's what delivered it, right there. Now, here is, from the 0Z run, the mean 500 millibar pattern 8 to 10 days in the future. So this would be valid from, got to read the fine print here. Valid, well, let me just do the math. 8 days from today is next Friday. So this is roughly the mean 500 millibar pattern from next Friday through next Sunday. And the positioning of this mean trough has, although here in the GFS it's moved north, in the European it's kind of moved to the east, this at least allows the possibility of getting a lot of Pacific air to flood the United States. And this configuration out here, the positive height anomalies to the north of negative height anomalies, this kind of configuration, which is common between the two, it's a fairly stable configuration at 500 millibars, suggesting to me that even beyond this period, we still should be flooding the United States with a significant amount of Pacific air, which to me means it just can't, except maybe for a very brief period, get obnoxiously chilly here. And so by that time, we're into the 3rd week of March, and the sun angle, you've essentially broken the back of winter. So I'm hopeful that the end of winter is near. I'll just show one more thing, and then we can talk. So here's the 14-day State College thickness pattern, something that we've been looking for a while, that even beyond, say, 7 days, there are some outliers. I'm just going to ignore this for the moment because I I'm going to wish cast and pretend that these things don't exist. And I know that's always dangerous. And certainly there is some suggestion that beyond the end of next week, that there's a cooler regime in place. But a cooler regime in place during the latter half of March is very different than a cooler regime in place during the latter half of February. So I will take below average temperatures the last 2 weeks of March as opposed to the last 2 weeks of February.
What was the lower image?
Well, these are the ensembles from, and they don't always show up, Rich. These are the ensembles from the Canadian model, and these are the ensembles from the no-gaps. So, who was I talking to yesterday that was really in love with the Canadian? Oh, I can't.
And the GEFS is above it?
Yes, and this is the GFS. So this is the, you're looking at the, I'm sorry, I did not explain this graphic enough. You're looking at the 1,000 to 500 millibar thickness from State College as forecast by the GEFS, each ensemble member, plotted over the next 14 to 15 days.
So after the 12th is...
So after the 12th, there's certainly some uncertainty.
But no gaps, very...
Yeah, the no gaps looked colder, well, and confused.
It doesn't have enough spread. Something dispersed. Something wrong.
So anyway, what would anybody else like to see or talk about? Yes, sir.
Following the GFS ensembles, I guess over the last week, it's been interesting that this pattern has shown up in the models, but there's been times where it wants to build the ridge over the western U.S. again. So, I guess it doesn't surprise me. There's still
out here.
Yeah, it's still showing.
The Nese BC, the combination of the top two plots, do show that after the 13th, the ridge of western Turkey is back. But it's too late, like you said. There's no blue. It's not very cold. So.
Fred, is Fred here? Fred used to have climatology on here. There would be a green line representing what the average 1,000 to 500 millibar thickness is, so we could gauge where we are with respect to climatology. And my suspicion is that even that out here, Paul, would you say 546 is climatology now for the 1,000? Late March, or would it be higher than that?
I'd say the 15th to 20th of March, 546.
546 probably reasonable. So climatology out here is 546. So I'll take that. To some sense, it's relative to what we've been through.
So
any other observations about the storm right now? Any interesting obs that anybody heard of from?
Well, from viewers that are writing into me, eastern Cumberland County and right towards Harrisburg, there's like a weird 4 to 6 that developed so far, and it's all been in this banding that's occurred. Other places, we've been getting reports, Mifflin, Juniata counties, just southeast of here, between 1 inch, 2 inches, and then a lot more as you keep dropping closer to the Mason-Dixon line. But there are some localized, very heavy areas, very wet, heavy snow that accumulated quickly.
And I think it's worth mentioning that the air coming in behind us in the Mid-South, you'll be hearing about record lows being set tonight and perhaps even tomorrow night in the Mid-South, sort of your Tennessee, Kentucky, northern Mississippi, northern Alabama, perhaps even to the Gulf Coast. And some of those could be all-time March records. We're early enough in March.
Interesting. This is like the third deformation type band with the 2 anticyclone snows, and they were really poorly handled by the models. The models kept showing everything was going to be further south, and then even in Kentucky, everybody dropped the snow further south. My son lives in Louisville. They originally said they're going to have 14 inches of snow 3 days ago, then they dropped it to 6, and he's over a foot.
Well,
and that happened here too. I think we got a foot pushing south, and it came back at the end. It came a little further north. Yeah.
Well, it's my experience that these anafrontal type snows are really hard to predict.
Yes.
And perhaps that's being manifested there.
It was a tough. It looked like the snow was sliding south, and then everything was pushing so further. And then it came back north in the evening one. All the runs.
Yeah, it looked like it was dependent on the speed of the high over the Dakotas and how that was projected. And
John Kerr, former faculty member, predict the high, predict the storm. I mean, the highs are the Rodney Dangerfield of synoptic meteorology. They don't get enough respect, and it's the truth. Rodney Dangerfield is, for those of you who are too young, is a comedian who is famous for saying, "I don't get no respect."
Just watch Caddyshack.
Just watch Caddyshack. That's right. What other movies was he in?
Oh, a lot.
A lot.
That's the best.
Caddyshack 2, right? Was there a Caddyshack 2?
I don't know.
Anyway, I know it's 1 o'clock and everybody has places to go and things to do. But thank you for coming and have a great spring break.
Thank you, Dr. Beam. Thanks, everybody. See you the week after break. Or the week after break.
Yeah.